So when we are confronted with the formula of a compound and we wish to give it a name, we're going to be kind of starting like this. Our first decision that we're going to make is it ionic or is it covalent? If it's ionic, there are a couple of choices that we have to make at this point. We have to decide, is the cation fixed charge or is the cation variable charge? There's also another choice that we have to make. Some ionic compounds are bases and some ionic compounds are not bases. So it turns out that that doesn't really affect the naming so much, but it does affect the classification of the compound. So we're going to be talking about how we can recognize what are referred to as Arrhenius bases in this video. When we look at the naming of covalent compounds, which we haven't done yet, we have a slightly different choice. Covalent compounds can be classified as either being acids or not acids. Now, we said that when we classified ionic compounds as either bases or not bases, it didn't affect the naming of them. However, when we classify covalent compounds as being either acids or not acids, it does affect the naming. So acids have different names from all other classes of covalent compounds. So we're going to learn how to name acids in this section. So let's define what we mean by an Arrhenius base. So an Arrhenius base is a compound that when you dissolve it into water to form what we call an aqueous solution, so a solution in water is referred to as being aqueous, and it's often indicated that a substance is dissolved in water by adding AQ to the end of its formula. When these compounds are dissolved in water, they form the polyatomic hydroxide ion OH-. So most of the common bases are ionic compounds that contain the hydroxide ion, and probably the most famous is sodium hydroxide, which you'll find in products like liquid plumber, and it's often referred to sort of in the very ancient literature as lye. So when you have the ionic compound sodium hydroxide dissolved in water, it's a crystalline material in a solid state, but when you put it in water, the crystal falls apart and it forms individual sodium ions with a +1 charge and individual hydroxide ions with a -1 charge. So how do we name ionic compounds that are bases? Well, it's pretty simple. We name them exactly the same way as other ionic compounds. So it doesn't affect the naming. So this would just be referred to as sodium hydroxide, which is going to give the name of the cation and follow it with the name of the anion. So the most well-known and the strongest of all of these Arrhenius bases are the hydroxides of the group 1A metals, the alkali metals, and then the hydroxides of the heavier alkaline earth metals. And they have to be the heavier ones, the ones that are larger than magnesium, because the others don't dissolve in water. So obviously they can't form hydroxide ion in water if they don't actually dissolve in water. So the nice thing about this is because the common hydroxides, the common bases, are all involving cations from either group 1A or group 2A, we rarely need to use Roman numerals in the names of these guys. So LiOH, we just name it as an ionic compound, it's lithium hydroxide. No need for Roman numerals for the charge on the cation because lithium's in group 1A. Sodium hydroxide, name of the cation followed by the name of the anion, again because sodium's in group 1A, no parentheses required. Calcium hydroxide here, calcium's in group 2A, means that it has a +2 charge, which is why we've got 2 hydroxide ions there. So it's calcium hydroxide. Again, no need for the Roman numerals because anything that's in group 2A, we always know it's going to be going to form a +2, and we don't have to indicate that. All right, so Arrhenius acids are not ionic compounds. Arrhenius acids are molecular compounds. But when they are dissolved in water to form an aqueous solution, they release hydrogen ions and some kind of anion, right? So, for example, hydrochloric acid, a very famous acid, when that is dissolved in water, forms hydrogen ions and the chloride ion. And as I mentioned, that these compounds, this class of compounds, have a different naming scheme from all other molecular compounds, and we have to learn that naming scheme. Now, how the acids are named are according to the anion that's formed when they're dissolved in water. So the most important thing is you have to identify the name of the anion that is formed when your acid is dissolved in water. So I'll kind of give you a few hints on doing this here. So acids have to contain hydrogen because they form H+ when they're dissolved in water. So their formulas always begin with hydrogen. So we've got H3PO4. This is going to form 3 H+, and then it'll form 1 PO4 3-. Note that the number of hydrogens is always going to be equal to the size of the negative charge. So if I go to H2SO4, I know that my anion is going to be 2- because I'm going to make 2 hydrogens. So similarly up here, because I've got 1 hydrogen in my formula, I automatically knew that the charge there was going to be equal to the number of H's, right? So that's kind of a little helpful hint. So what we have to do is figure out the name of the anion formed in every case, and then we can begin to apply the rules for naming acids. So the anions that are formed have 3 endings. They either end in IDE, they either end in ITE, they might end in ITE, or they're going to end in ATE. And the rule that we have for the naming the acid depends on how the anion's name ends. So the most complicated one is when the end of the anion ends in IDE, when the name of the anion ends in IDE. And when that's the case, we write the prefix hydro, then we give the stem name for the anion, then we end it with ic, and finally we follow it up with the word acid. So here's what we had previously. HCl dissolves in water, forms H+ and Cl-. Now we recognize that Cl- is a monatomic anion that we name by giving the stem name of the anion, following up with the ending IDE and the word ion. So this is an ide, right? How do we name ides? Begin with hydro, give the root name of the anion, which in this case is chlor, because it's a chloride anion, end it with ic, and then add the word acid. And so you can see I've color coded that all the way through there so you can follow it. So that's how we name the ides. And remember, we've got to name the ites and the ates as well. So the ides become the hydro, just put ic acids, right? So whatever your ide is, it's going to become the hydroic acid, and X just represents the stem name of your anion. Okay. Something to be aware of is if you have a molecular compound that contains hydrogen and it's not dissolved in water, you only name it as the acid when it's dissolved in water. So we're looking for this like AQ at the end here. Okay. If it's like not actually dissolved in water, we won't name it as the acid. So if it talks about it being a solution, or if it has AQ appended on the end, or they're just generally talking about it as an acid, we're going to name it as an acid. If it doesn't mention that it's an acid, if it doesn't mention that water isn't present, we're actually just going to name it as a regular molecular compound, and we'll talk about how to do that later. So this is not so important to you, but what I want you to be aware of is sometimes you'll see things with the same formulas named in different ways. They're not wrong. They're just discussing a different scenario because the definition of the Arrhenius acid requires that your compound is dissolved in water, and it's not actually an Arrhenius acid if it's not dissolved in water. Okay, so oxoacids are ones which form oxoanions when they're dissolved in water, and remember your oxoanions are going to have endings of either ate or ite. Now, if your ending of your oxoanion that is formed when your acid is dissolved in water is ate, then you end up with an ic acid. So this is the nitrate anion. So the acid which forms that is referred to as nitric acid. So your ates become ics. Now, if the anion that is formed ends in ite, then the acid that forms that anion is an us acid. So this guy forms the nitrite anion. So the acid that formed it must be nitrous acid. So it's a pretty simple thing. So we've got one rule for the ides, another for the ates, and another for the ites. So you have to name the anion and then work backwards to the name of the acid. And we've got three fairly simple rules. The most complex one is for the ides, where it becomes the hydroic acid. Okay, so when you're naming these compounds, you're going to kind of need to follow a systematic procedure. The first thing you got to decide is your compound ionic or molecular? How you're going to be doing that is looking for a metal or the ammonium polyatomic ion. And if that's present, you know that your compound is ionic. So if it's ionic, you're going to name it then according to the rules for ionic compounds. And the main thing here is to be looking for a variable charge cation and seeing if that is present, because if it is, you have to put the charge of the cation in Roman numerals in parentheses. Now, what if you decide that it's not an ionic compound? Well, if you decide that it's a molecular compound, what you're going to do then is check to see, is it an acid? Do they tell you that it's an acid in the formula? Does the formula begin with hydrogen and end in AQ? But you need to decide if it's an acid or a non-acid. If it's an acid, you then got to go through and figure out what is the anion formed when it's dissolved in water. And once you've done that, that's going to lead you on to the name of the acid. Okay, well, I hope that was helpful. And so we know how to recognize bases now. These are metal hydroxides. We don't have to do anything special with the naming of these. We're just going to name them like ionic compounds because they are ionic compounds. And then we also learn how to recognize acids. So we know what these are. These are hydrogen-containing molecular compounds. And how are we going to name them? Name according to the anion. You have to identify the anion that is formed when it's dissolved in water and then apply the rules for the ides, ates, or ites accordingly. Okay, hope you found the video helpful.